Hello and welcome to Chapter 18 Homework Videos. Here we are in the Nursing Chem Lab. Thought I'd take you on a little adventure today. So conceptual questions, numbers 1, 5, and 9, are dealing with questions starting with number 1. There are very large numbers of charged particles in most objects. Why then don't most objects exhibit static electricity? So most objects, my pen included, are made up of a large number of atoms. Each of those atoms has protons and electrons, an awful lot of protons and electrons, so a whole lot of charged particles. But it's not exhibiting any static electricity because it's an equal number of protons and electrons, and if you have an equal number, then they come out to be electrically neutral. Number 5, when a glass rod is rubbed with silk, it becomes positive and the silk becomes negative. Yet both attract dust. Does this mean that dust has a third type of charge? Well, no. When you have a negatively charged object and you bring it into proximity to a neutral object, any neutral object, but particularly a small thing, that neutral object that had an equal number of electrons and protons all just kind of spread out everywhere, when the negatively charged object comes near it, draw it over here near it, it exerts this electric field that repels the electrons, and the protons don't care, so they kind of stay put. So the protons stay, the electrons go away, and then you have this electrostatic interaction between the negatively charged object and the protons that are nearby. That is the case of static attraction. It becomes polarized. So this object is polarized. And it's the same deal if I charge something up and it becomes positively charged by removing electrons, then this other object will become polarized, but it'll become polarized by attracting the electrons to this side. The protons stay put. There's still some protons here in this region. Protons don't move around very well. The protons stay put, and the thing becomes polarized, and then this electrostatic attraction, it attracts it. Ultimately, it would be attracted. Once it touches the object, some of the excess electrons will jump to it. Then you have two negatively charged or two positively charged objects, and it would be repelled. But we don't need to take the story the whole way. We just have to point out that there is no third kind of charge. The next one, we have this image of a water molecule. It's called a polar molecule because it has an inherent separation of charge. Given this character, explain what effect humidity has on removing excess charges from objects. Water molecules are polar, meaning kind of like this thing that we just drew. We have our hydrogens with partial positive charges and our oxygen here with a partial negative charge, meaning that those water molecules can be attracted to either a negatively charged or a positively charged thing, depending on how the water molecule orients itself in space. So on a humid day, there's a lot of water molecules around. They will be attracted to anything that has charge, positive or negative charge, and that will give it a bigger surface area, a bigger possibility of attracting something that will neutralize it. Because in every cubic centimeter of air, there's about 1,000 ionized pairs, positive and negative pairs. So there's always the chance for something to get neutralized. So that is what goes on there.